Today is our Hancock Academy session 6, and it's an introduction to heat. We're not going to go into too much technical detail, but we're going to introduce you to all the different housing types that heat can energy model. The idea of the class is to show how you could use one energy modeling tool for all types of energy audits. So today's webinar, we're going to go through first, in the first third of the class, we're going to go through single-family energy modeling. And for that, we're going to use the mobile heat iPad app. So we're going to have a combination of different things today. Then we're going to show you manufactured home energy modeling, and Art and I will stay online for that one. Heat is recently designed to model manufactured homes, so this might be new for a lot of you. And we're going through all of the DOE approvals associated with that. So it is a new thing for us, and we're excited to introduce it to our user community. Finally, multifamily modeling. Today, heat can be used for garden-style units. Art, is it how many stories?
That would be 4.
About 4 stories or less. And you can model that as one whole unit, or you could decide to model each separate unit within the house, within the complex. It is on our roadmap within the next year to expand heat to model high-rise. And Art can talk about like some of the changes that are going to go into that, so we'll touch on that too. We have at least an hour together, so please ask any questions that you may have as we go along, especially since we have our technical expert here, Art Wilcox. Let me just make sure we don't have any questions so far, so let's get started. Art, if I ever have any technical difficulties, or if you do, we'll let each other know, okay?
Sure.
Okay. So we have these 3 types of houses, and what we're going to do today is show you the building types and how that drives the energy audit. And then we're going to dive into some more detail of how you would approach an audit. And Art and I are going to start by doing the envelope of the home. Then we're going to do the mechanical systems and baseload. And then we're going to do other like CAS testing, health and safety, or other ventilation measures. We'll take it slow, so you have chances to ask any questions you may have. Okay. And it logged me out. So what I first start is I'm going to start that single family residential. And let me zoom in here. Okay. And what triggers your audit to download to the mobile app is that it's scheduled to you. It's in a scheduled status. So you can see my iPad project on the screen, and you can see that Heat mobile app icon. The way you get this mobile app on your iPad is you go to your internet browser on your iPad, and you go to your online site and you log in. And in the bottom right, you're going to see Try Our Mobile Energy Audit, and you tap it. And that's what installs it on your iPad's dashboard. So I have already done this before the webinar. I open it up, and I can see a list of jobs that are scheduled to me. I have 3 jobs: sample, random, and myself. These are all single-family energy audits. So we're going to start with the single-family audit, and then we'll move to the manufactured home. So the way the single-family audit downloads is on your master job list. You make sure that the status is scheduled and that you are assigned the auditor and that the job's not deferred or denied. So here you see these 3 people match what's on my audit. Now let's look at one of these and talk about how to approach the energy audit and what's actually going on a little bit behind the scenes of the energy model. When I first opened this up, two icons are going to be pre-filled for me. That's the client information. Here I can see, if I can show all the energy consumption, so I can see immediately that this house is a gas and electric house. It uses about 800 CCF or therms of gas, and it uses not too much. It uses about 6,000 kWh, so it's primarily heated by gas. I can see any notes that the office staff left in, and then finally I can map the house in order to help me get there. So I'm not really changing any information here. If I did need to change any information, I could go here and edit and change the information. You can change anything, I think, except the person's name. After that, you can view the energy consumption. And the energy consumption is broken down into a lot of detail in heat. You see the total annual, or you see the total monthly if I had ticked this box. But further than that, I see how this annual is divided into the subsystems. So Art, can we stop there for a minute, and can you tell me what does heat do with that billing data? Let's first start at that point. What does heat do with that data that we entered on the energy consumption screen?
Well, it simply is going to give you a record and allows also to have pre and post records, but there is not an automated calibration process of your modeling or estimated consumption against consumption that is directly entered based on billing history. We may be moving to that, particularly within multifamily setting. Most of those algorithms, I think the latest one is a BPI-ANSI approach, and I assume based on some statistical methodology, probably multiple regression. But what it's going to do, if you have an automated approach, if we go to that, is that it's going to modify the existing modeling to true up as closely as possible to the actual billing data within a certain range. But right now, it's incumbent upon the auditor to use that data, knowing how good it is, because it may be downloaded at some point directly from the utility, which may be good data, and it may be limited to half a year, who knows, or you may be entering it off of a client's bill. In either case, it's up to the auditor to determine its usefulness. How accurate is it? Is it complete? From there, it would be used as a sanity check against each of the end uses. If you modeled a house at 100 million MMBTU, let's say 1,000 CCF, and you had comfortable billing data in there for heating for that end use, and it was gas, and it was 875 or 900, if you're in a 20% range, that's a good indication that your modeling is appropriate. If you have something dramatically different and you believe it's good, then as a sanity check, you should look for where is the most likely area or areas that you modeled that you have the least confidence in. Because it is sometimes hard to determine the quality of the wall insulation, depending on the time of year, equipment available, etc. The actual AFUE may vary more or less than one would roughly estimate, in which the software estimates, based on your steady state, whether using backward or some other approach to get a steady state efficiency. So whichever, whether it's the attic, the crawl space you're not going to get into because you see a lot of rodents and other furry things down there, and you can't really tell how secure that insulation may be. Those are the types of things where you may have to, using your experience, make adjustments, make appropriate adjustments. ultimately, that's what any automated tool will do in the future, but it takes out the house-specific adjustments that the hands-on person would make in terms of confidence adjustments, and it applies a algorithm to it that's applied to every job, where the highest lack of confidence is in heating system if it loads. And then it goes to walls, and then it goes to attics or windows, whatever that algorithm is.
So Art, what you're saying is now like heat doesn't use this information. It's more of the auditor, a way for the auditor to say, this is the actual usage. And we're going to show you later in the demonstration how you compare this actual usage to the modeled usage.
Right.
But down the road, we might actually calibrate it for the auditor.
Yeah. The other side of this is it's important that you put usage in, even if it's just an estimate, because the system is going to want to know that there is an actual fuel consumption record for that end use.
Okay. So after the energy consumption, then the first point of data entry for the auditor is going to be building information. And you're just going to go right down the line. The first thing that's going to show in red is the state and city. So heat supports all 50 states plus more. And it supports TMY3 weather data within each of those states. So that means just a more expansive list. Here you can see an example of Pennsylvania. You're looking at probably up to 10 or a little bit more weather data stations here. So when you select this, Art, could you just briefly explain in the background, what does TMY3, what is it doing with the data tables when you select that weather location?
When you select the weather location, it's a bin to hourly 5-degree bin approach, which all tools use, and it captures the degree hours in those bins. So if you pick any given city, then that information is used to determine the heating and the cooling loads. All softwares have the ability also to define a range of bins that is going to be used. So you may have 10,000 degree hours or 20,000 degree hours, but you may not use the information in the 65 to 70 degree bin or even the 60 to 65, because studies show that heating systems don't come on if you have a setting of 68 and the outside temperature is 60 for a period of time. But in any case, those are critical, and TMY3 is the best weather data, 30-year averages, that is out there, and it has improved. We were using TMY2, but the TMY3 gives us better information for degree hours and also more sites. So you can pick usually 2 to 3 times. Your list of sites will be 2 or 3 times longer than it was with TMY2 data.
Great. So after the weather's picked, then the first part of the energy modeling is to define the total square footage. Heat gives you 2 avenues to do this. You can, like I did in this example, I said it has a basement, a floor 0, and a first floor. So here I'm identifying each length and width, my 40 by 25 foot house, 8-foot ceilings. If it's not your pattern to do each floor, then you can just go right in here and type the total square footage when you look at the house. But the important part is that you allow heat to calculate the total square footage and the total heated volume. Art, how do we use this later on? How do we use this as I go along in each energy audit section, just generally? Did you hear me?
I'm sorry, I accidentally hit the mute.
Oh,
the heated volume is the heated volume is used to be used in the calculation for ventilation, building ventilation purposes. It impacts also air infiltration calculations. Those are the two main purposes.
And the other part of the main section that you might want to touch on is, in addition to energy modeling, we've built some calculators in, like the ASHRAE ventilation 62 2013. Some of these, like Art, is it number of bedrooms, or which of these are used in the calculator, such as the ASHRAE 62 2013?
It would be potentially the number of bedrooms. It depends on the difference between the number of bedrooms and the occupants that are recorded in the record.
Great. So when you first approach the audit in the building information, you're going to enter, again, to review the total house dimensions. And you're going to set that weather bin data by setting the state and city. And then if you plan to use the calculator like the 62 2013, or if you plan to use track SHPO like the year built, then you want to make sure to go to general info, enter the year built, fill out the ventilation information, the number of bedrooms. And that sets you up to then do the first part of our agenda, which was the envelope. So we're going to look at the envelope of the house. The envelope is in the bottom section of heat, this row of icons. It includes the shell of the house plus air sealing and blower door tests. For the heat energy model to run, you do have to do a blower door test. Let's start by sizing up, let's say, the wall, the perimeter of the wall. When you maybe are still standing outside of the house, you do this, or you walk into the house and you do this, you roughly measure the dimensions of the house. So here I have, I had that rancher, so I have 4 entries. If you have a 2-story house, you would still have 4 entries here. I know I have 4 entries because it says 1 of 4 pages at the bottom. And each of these entries are 40 by 8 for the east and west side, and then they're 25 by 8 for the north and south side. If this was a 2-story house, I can always set that section quantity from 1 to 2, and that would tell the model that the volume, that area of that defined space is doubled. Art, what is that square footage here doing?
It's part of the load calculation. It's the same in all of the heat transfer surfaces, whether floor, attic, or walls. It contributes to determining the size of the load. The higher the net square footage, which is simply subtracting the windows out that you put in, gives you the load coming through that wall, along with the degree days and the basic building science algorithm.
And how about buffered zone? If I were to tag, let's say on the other side of this wall is a garage.
It simply adds on an additional R value that's appropriate for that buffer zone. So it simply increases the R value.
And for this demo purpose, my information's already filled in. If you're first approaching this house, you would tap Add New, and you would get a blank screen. But when you add the next section, the next wall dimension, you can see that it defaulted to the previous wall dimension. So that's a new feature in Heat. Heat will assume the same entry as you previously entered, and that's just because we heard some feedback where entering walls was took a lot of time. So these are things we can do to help you save time. So when you press Add New, it just defaults all of the entries, and you would change the direction. In some cases, you may have to change the width. After I define the wall space, I usually go and define the windows. I go to the window icon, and I take it like in all one fell swoop. I look at this house and I say, there are 15 of these windows, 2 of these, 4 of these, something like that. Another way to approach it is to go to one wall and define all window by window on one wall. So it's flexible. You can do it either way. In this house example, I had this standard type of window that was 36 by 54 inches. I have 5 of them. And then I had a smaller window that was 24 by 36. I only had 1 of those. And then I had 2 doors. So I just took care of the front and the back door. After I define that, I can then go and I place those on the wall. So you can see on that first east-facing wall, I have that window. A little heat hint that helps me here is I add the dimensions to the name. So when I go to place it on the wall, I easily know I'm picking the right one. Anything else do you have to add Art about the walls in the window for the single family?
No, just be aware that depending on the orientation of your wall, that will affect the load on that window because of the solar data that we use.
You're going to see that solar data pop up, I think, on the windows, right? Do you see the solar data? Is that with the solar heat gain coefficient?
No, that's the solar heat gain coefficient, which simply impacts how much of the photons that are hitting that window come in. So it's just a modifier and a characteristic of a window.
Okay. After the walls and windows, then I would do the attic, but I mean it's any order that you would like. In the attic, you can see when I open this attic, you see 2 records, one for the access and one for the unfloored. So if I'm like treating an access, that's when I select access. This might be if I'm adding insulation, if I'm building an access, if I'm adding an attic tent cover, anything I'm doing, I would select the section access. And the main thing that you have to be careful of is those dimensions would be very different than the total attic dimensions. So my total attic dimensions are 40 by 25, and I think my access was about 2 feet by 3 feet. And that triggers the square footage calculation. You're going to see some other drop-down choices here. And framing Art, that always really affects the R value, right?
Yes, the framing options always impact and almost always reduce the overall R values.
Then for single family, you're going to see other inputs that aren't actually energy modeling. But for manufactured home, these inputs come into play in the energy modeling. Is that correct, Art?
Yes.
Okay. So for now, we're not going to go into the details, but roof type, roof material does not have an impact on single family home energy modeling, but it does on manufactured home energy modeling.
Yes, it will, simply because we need to, because of the smaller volume in the attic, we have to calculate a space temperature.
As you're going through, if you want to recommend measures, then you tap the measure, and you can recommend measures. In this instance, in heat, in the attic, you can recommend 1 energy savings measure per section. So here you see the insulation, and then you see other ancillary or incidental measures such as the eave chutes and the insulation dam. And in heat, a hint is you know something is energy savings because of this box here, this X. When you choose the measure, it pulls the price for you if you have a price list. So if you're wondering how you get a price list on the online site, you can go to a screen called Agency Measures, and you can define your own price list. So if you wanted to define pricing for attic, you tap attic, and you would then be able to select the attic measure and define a price list. Or else your state may use statewide pricing. In that case, the state defines the price list through an administrative screen. After the attic, the foundation includes a slab. It includes conditioned, unconditioned. It includes a vented or unvented crawl space. And it can even do a combination of any of those things. So here you see a basement, and the idea is you can add new, and you can set complex basements or regular. In heat, when you see the word complex, tell us in real life, what does that mean?
It means that it's either a crawl space or a below grade area where it's important to calculate an annual space temperature for that basement. So there are basically a couple of types. That is a full below grade basement, and the other is a crawl space of one sort or another. We break it down a little bit further. The below grade ones, soil temperatures are going to impact the overall space temperature.
So you can see in my example, when I added the new basement, I'm given the choice of what kind of basement I want to model. Mine was unconditioned, so you'll see unconditioned complex. But you'll see those other basement types I discussed: vented, unvented, and conditioned. So if you're modeling a space like that, you would choose one with the suffix of complex. Conversely, if you're modeling a dirt floor or a slab, it doesn't need that sort of year-round temperature. It's just the flat surface. You can choose that. If you choose a complex option, it actually tells you what you need to enter. So if I choose condition complex, it then tells me, well, for a conditioned basement, heat requires you to define the above grade space, the slab, the below grade space, and the sill. Now that's a little different. If I do unconditioned, I'm going to also be asked for the space, the floor above me. So if I change that to unconditioned, you'll see I have the same options plus the basement ceiling above me. So it's an easy guided way to know exactly how to correctly model a basement, to choose this complex option, and then heat will tell you which entries to model. Okay, we're at 1:30, and I do want to get through these different building types. So the blower door test is very straightforward. You enter the pretest and a target. If you wanted to run the ASHRAE 622 2013 calculator, you tap building ventilation, and before I even enter anything here, the calculator runs. Then you add the ventilation, whether it's existing or if you're adding it. Affected is for bathrooms is, I think, 75 CFM. Art, is that true? Or 50? What is the definition of affected? Do you know?
The definition of effective is for the bath is I believe 50 CFM or less.
Okay, so if your bath is running at 50 CFM or less, you check this. Mine's at 75, so it's not checked. So I add my ventilation, and then the calculator displays the results. Notice, like as compared to the red calculator, I'm not entering number of occupants. I'm not entering my pre and post blower door reading. I'm not entering that other data because heat already grabbed that from your previous data entry. Art, anything to add here?
No, we've done, we've made an effort to match this calculator as best we can to currently used calculators. If there are any questions specific about it not matching a given way you use another model, then and simply let us know what your issue is.
Okay. So you can use that calculator to come up with the target, or you just enter the target. The energy model will use the target CFM, that difference, until you enter the post-test. So it will use the target. Next, for the mechanical systems, we mentioned that this is a gas heat. So this is a forced hot air unit that's used 100% of the time. This usage ratio lets you model multiple heating and cooling systems within the same household. If I only say maybe 75% of the time, I could put a 25% wood stove, anything that the combination. There is a question, and that's a good question. Chris asks, before we leave that ASHRAE 62-2013, the kitchen. The kitchen affected definition, I think, is 150 art CFM or less.
Yes, and maybe I'm checking now. I believe it's that's what it is. I'm checking now.
Okay, Art, you can just type it in the chat box to everyone. But I think an affected kitchen CFM is 150 CFM or less. Fuel switches. We also get asked about fuel switches. Yes, you can switch fuels in heat. Heat will model that. You would have to remove the existing system. So if you are removing this fuel, you would have to remove the existing system, then add the new fuel. If you're doing fuel switches, then you would have to go to the energy consumption and add the new fuel and signify that it's a fuel switch. And that way, heat will know that that's the new fuel you're using. If you're accounting for the central AC load or the room AC, in this case, in this housing stock, we run into a lot of room AC. So here, it's a room AC, which affects 500 square feet of the house. So that is about half of the house's total area. And then it asks you for the nameplate and the EER. So you can see any kind of combination of central AC, space heating, and room AC. Thermostat is optional. Heat defaults the thermostat settings. So you'll see heat defaults a thermostat setting. If I go to the energy savings report, you can see the thermostat setting heat defaults is, I think, 68 and 78. And you can override that. And to override that thermostat setting, that's what you would use the thermostat icon for. After that, we're ready to get into other baseload consuming. So the refrigerator, what you do is you account for the total annual usage. I have annual usage selected here, and that lets me just type in the total usage. If I had metered here, I could search a database and it would default the metered readings for that age of a refrigerator. Lighting, I like to treat lighting just in a few entries. Here I only have 2 entries. I don't go light bulb by light bulb. I say it's the lighting. I usually select other or interior. And I'm saying I have about 12 bulbs that run at 60 watts. And I'm replacing that, in this case, with CFL. I also have some 5 bulbs that are about 100 watts, and I'm replacing that with CFL also. This is where in heat, with any section, you can take a picture. So you can tap the camera icon and take a picture of the condition. Hot water is, within the past year in heat, it's been divided into 2 icons. The icons are the actual tank usage, so it takes it uses like the energy factor and it uses the temperature and the size, and it models the pre-usage and the post-usage, and it models it right on the screen for you in CCF. So if I press that calculate button, heat is telling me, and this is a good way for an auditor to make sure this is reasonable. Heat is telling me that annually my hot water tank uses about 208 therms or CCF. Since I'm not doing a replacement, the post-usage is the same. If I'm doing a replacement, I would expect to see that post-usage to improve. Now, the hot water install, the DHW, is for kind of like measures you're going to install usually right on site. These are going to be aerator shower heads. The difference is it uses a savings percentage. It's not really using energy modeling per se. It's saying like when you do aerators, you're going to see a 1% savings of energy. And then you'll see the total usage, and you'll be able to just go through the line. Let's say I was going to do a shower head here. I would just press add new, and then I could find the shower head. The cost could default for me, enter the quantity, save, so I can go right down the line. Check Art's answers for the chat. He answered the ASHRAE questions for the bath and kitchen affected fan. So let's go on to other health and safety and combustion. Combustion tests are in the CAS testing is on the combustion safety icon. You can do a worst case depressurization test, spillage, and carbon monoxide. You can record whether it passed or fail, and record the parts per million, the ambient carbon monoxide, the CO levels. The combustion test, on the other hand, that's kind of like when you're testing a furnace and you have that tape. It's just a way to record the tests. And finally, CO test is when you're doing the CO levels, for example, on a burner, on a cook stove, you can record the CO levels. So this is not used in any energy modeling. This is just to record the health and safety effects of the house. To run the single family energy model, you press energy savings, and SIR comes up. This is 0.76. And then you see the total savings annually and lifetime in one fuel, and it's MMBTU. So it's a standardized unit of measurement for all the different types of fuel. Then you see each energy savings measure and the individual SIR for each measure and the savings. Separately, you're going to see health and safety. You're going to see each health and safety measure and then each base load. So I entered those refrigerator information, the lighting information, the hot water. And then here's where we tell you the savings based on fuel. Remember, my house is gas and electric, so I see my gas savings. I separately see my electric savings. So this is what you review, and this is what determines if these measures are allowed on a work order based on the individual per measure or the total job SIR. And then when you're done, you upload it and it goes back to the online site. Now I want to take what we did and I want to expand that to a manufactured home. So are you with me again?
Yeah.
Okay. Manufactured home, what are the differences? What I showed you is when you select a single family home as the building type. But if you select a mobile home and you do a full house audit, you're going to see changes on the audit information, the attic, the wall, and the basement screen. So we're going to go through that right now. So let's sign into a site that has a manufactured home modeled. And actually, we do have a question, so let me answer this question. Oh, we do have a couple of questions. All right, I'm going to ask you these questions. Fuel switching. For fuel switching, is the original fuel the baseline, or if you fuel switch, does the new fuel become the baseline?
The baseline will be the original fuel. The savings will be calculated when converted to gas, for example. So the cost of the post fuel will give you the multiplying factor against the CCF, for example, that's saved.
Mm-hmm. Got it.
So I mean, ultimately, you'll see it. You'll see the pre showing the value there, but it really does depend. That can vary. Fuel switching is a difficult thing depending on the funding source. So sometimes it's that, sometimes it's pre and post for the replacement, what you're switching to. It depends on how the funding source wants to collect that information, but it's all in MMBTU anyway, so that's we can make adjustments for that.
Okay. The next question Teresa asks is, this total cost, when I showed the report, does that include labor? Yes,
the
right?
Total,
mm-hmm.
Yes, the total cost is material and labor costs for the job.
It's a little odd in a way that when you use heat, only the material cost shows when you're actually typing in the measure. Like it only the unit cost, the material cost displays. The labor cost is there, it's just not displaying. But when you go to that energy, that final energy savings, the labor cost adds to the unit cost. The next question is, on the energy savings report, in what order are the proposed measures listed on the report from top to bottom? How is this organized?
Highest SIR to lowest.
Okay. Art, I just grabbed a manufactured home, so maybe we can move through those differences pretty quickly.
Sure.
The first thing that made Heat say that this is a manufactured home energy model and not a single family home is that on the client information screen, I selected manufactured home, or mobile home actually. I didn't select a single family option or a multifamily option. The second thing is that on the audit information screen, I set it to a full house audit. So you can confirm the energy modeling engine that's being used by coming up here and seeing that it says it's a mobile home using mobile home energy modeling. If this says it's a mobile home using single family or something, then that's a problem. So we have this mobile home, and Art, are you familiar with this? It's a 50. It looks like it's what is that, a double wide?
I'm not seeing your screen refreshing.
Oh gosh, I forgot to press play. I'm sorry, everybody. Okay.
Okay.
Thank you. We are on a 50 by 20, so is that as a double wide?
It could be more than likely, yeah.
Okay. Are there any differences on this screen with mobile home versus single family?
No.
The only thing is that you have it set at a full house audit, and what I was showing you before is that up here you want to make sure this says mobile home using mobile home energy modeling. And it came from the client information screen. All is the same here. So let's move into some detailed sections like, is heating and cooling pretty much the same, Art?
Well, we need to look at the distribution.
Okay, so let's look at the distribution. This is where we get our first difference. We open the distribution, and you're going to see immediately something that we'd never seen before in heat, and this is an idea of duct framing. Go ahead, Art.
Basically, this helps us to evaluate the overall efficiency of the distribution system, depending on how you characterize the way the ducts are insulated. That will modify the pressure pan reading calculation.
So what are some other options here?
Basically, 6 options, 3 for each, whether the joists are lengthwise or widthwise, and the ducts being below the insulation, below the joists, or within the joists.
Great. Next, let's go to some attic differences. How does a mobile home attic differ in heat versus that single family that we had showed before?
Yeah, fundamentally, the differences were, as with complex basements, we're calculating a space temperature. In this case, though, it's for the attic. To do that, we had to collect a bit more information, and some of it's behind the scenes, but the roof material is important. That affects solar gain. And the existing insulation depth is important, as well as because as you define, first of all, the roof type will affect the calculation of the overall R value based on the insulation depth. Whether it's a bowed roof or gabled or flat roof, it's going to modify the R value of the existing insulation depth. Because as you know, the less space there is in the quote-unquote attic, it may be virtually nothing to some kind of small bowed area. Those things all will affect the overall R value and the load calculation.
And if you see this SB and MH in your instance of the software, it's just site-built versus manufactured home.
Right. The reason in the mobile home you're able to select more than just mobile home roofs is some mobile homes do have single-family types of additions.
Great. Okay.
One last thing, you'll notice the peak and the edge height. Those are important entries relating to the actual available space in the attic.
So that's right there, the peak height in inches and the
Correct.
edge height in inches.
Yeah. Mm-hmm.
Okay, where else should we go to next to see a few differences?
Those really are the significant ones. Obviously, in basements, you are not going to see, depending on each configuration, and as we move to standardized ones, your drop-down list of section types will be appropriate to mobile homes. You rarely have a finished basement under a mobile home, I would guess. So there'll be configured sections appropriate to mobile homes, as well as framing options, sections and framing options, and you can see it there.
I can see some
but
belly
also,
cavity.
The last thing is the deepest and the shallowest part of the belly cavity, yeah.
So in a mobile home, you're modeling the belly cavity, and then we'll ask you for the shallowest and the deepest parts of that cavity.
Yeah, that's correct. We need to have those values to get the overall R value.
And then Chris asks, mobile home testing of ducts.
Mm-hmm.
Would that be the pressure pan?
Yeah. At this point, we have not built in the duct blaster. Most of our customers, if not all, have indicated that they're not using that in mobile homes for obvious reasons. So right now it's pressure pan based. So you simply enter your primarily the supply registers. Return registers are not necessary. Some states, in fact, remove returns because they're just sources of leakages, and they let the the return occur right at the furnace.
So to summarize the manufactured home here, for insulation, a few differences are you're going to be asked the type of insulation, the depth of insulation, because we're going to use that to calculate the existing R value. You're going to see new framing options for mobile homes, new section types and framing options, usually signified by the prefix MH to help you out so you know that's a mobile home. You're going to see some belly cavity information in the foundation floor section, and you're going to be asked to enter information about the depth of that cavity. And then this is something where, like a little hint in heat, heat is like tracked by modeling engine versions. So you're going to be able to see whether you're using mobile home or single family home. And remember, you can do that by going and hovering at the top. You can make sure that you're using that. Or on the energy savings screen, there is a button at the bottom that you'll be able to kind of like in light gray read what modeling engine version you're using down here. House types, everything we showed today is driven by house type, manufactured, mobile, or even multifamily. So what that means is heat tells, it's not like MIA and NEAT. It's not like two separate tools. It's like whatever you choose here at building type is whatever kicks into gear the energy modeling. So let's go a little bit to multifamily. Multifamily, we're not doing high-rise modeling yet, but our plan is to do that one day. So we're going to show you just a way to model very quickly in the last couple of minutes a triplex. So this is a triplex. This is a small multifamily. It has 3 units. In WAP Online, in the online site, you can enter the demographic information, for example, for those units. So after you enter the client intake part, then you can either go and create each unit. So here I have 3 units, and I could then open them up and energy model each unit, just like I did in the first half of the demo single family. Conversely, I can enter the whole project under the common area. So I could go here and I could enter the total energy consumption and model the dimensions of the project right through the common area. So pretty much we're saying today, multifamily energy modeling in heat is no different than single family. Is that true?
That's correct. It would just be the size of the building. I'm
going to ask you a question that I get all the time.
Yep.
How about those shared party walls? What do you do if I'm modeling each of these 3 units like I showed you here? How do you account for the shared walls in between?
You can just, for now, ignore them. They'll be assumed to be adiabatic, but going forward, when we do the final adjustments, one of the things we'll do is allow for some selection of a heat transfer wall between occupied and unoccupied units. There are just a few areas: air infiltration, that issue, and some heating plant issues.
And then talk to me about what changes are we going to make when we do that high rise? So I had on my slide deck, I had this high rise pictured. What does it take differently to model something like this?
Adjustments to the air infiltration. The higher up you go, anyone who's been on the top of a 6-story or higher building, you're not going to want to get too close to the edge with a gust of wind. You'll be taking a nosedive. So dealing with air infiltration differences at heights and then averaging them out over the whole building, finding the sort of middle point of air infiltration. So that's probably one of the biggest. The second biggest is the heating plant. You need to collect a little bit more information on more complex heating systems and integrated heating in DHW. That's not a huge change, but it'll allow some calculation differences also around distribution and controls. And a slightly different approach to calibration due to settings that are often external to the lifestyle of the residents and how to manage that. The architectural surfaces really don't change that much.
Okay, so let's just review. I think we just have 3 minutes to 4 minutes left to really reach the hour, and maybe we'll stay on just a little longer. So in case anybody joined late, they can still get the BPI credit. We showed 3 different housing types today, and then through that we showed you how to drive the energy model by setting manufactured mobile home versus single family building type versus multifamily. Then we went through the envelope section, and the main differences between manufactured and single family and heat are the attic and the foundation floors, and accounting for the surface and the belly and the cavity and the depth. Then we went through mechanical systems, and we showed a little bit of fuel switching today. So we showed how to model a combination of systems, and then what is involved in is if you switch one of those systems to another fuel. For baseload, we discussed the hot water heater, which actually uses energy modeling. So right on that hot water screen, you can see your existing hot water heater uses about whatever kWh or therm or CCF versus direct hot water measures like just changing an aerator or shower head. Then we went into combustion safety testing, and we went into other ancillary measures. And then we went back to mechanical systems and talked about the ducts. So we're using pressure pan methodology in manufactured homes. We're using both BPI and pressure pan in single family homes. Finally, Art discussed multifamily home energy modeling, how currently today we support garden style, but we are planning to do the all-in-one tool where you can do the high rise also. We talked about party walls. We talked about all the different systems. So I won't go into too much detail, but I will send this slide deck out so you have this to reference. If you have any questions today, you can email us after. The email address is on the screen. It's info@hancocksoftware.com, or you can ask them right now because we still have a couple of minutes. Yep, we still just have 2 minutes. So if you have any questions, you can ask. If you didn't submit your BPI number, then you can just email the BPI number right to this email, and we'll make sure we submit it to the portal. Art, do you have anything you want to say in closing to summarize using?
I just want to add a couple of things that we'll be getting approval to do changes to the single family side. One will be to change somewhat the calculation of attic framing, in particular where insulation overlays the framing, and we're going to be allowed to make those adjustments to improve the overall R value and not reduce it as much as it currently does. That's one. So, and I think that will make the loads and the savings and the SIR for high amounts of attic insulation to improve. And I think that's the largest thing we will be doing. And some states may be choosing to ask DOE if they can use what currently exists in the heating cooling dashboard to set thermostats in the house to account for diurnal or seasonal reductions in space temperature, particularly heating loads.
Okay, great. We run these academy sessions every 4 to 6 weeks. I'll be sending out a survey after this to please suggest rate us, suggest any content that you want to see. We want to make this useful for you all. So thank you so much for your attendance today. And I will be in touch with a recording. I'll send you all the recording of this. And if you have any other questions, just reach out at that info email address. Thank you, everybody.
One last thing, Danielle, I forgot. We will be also adding in the near future the ability to put in more than one complex basement per single family unit. Thanks.
Great. Sounds fun. That'll be a whole nother session. All right. Goodbye,
yes,
everyone.
It will.
Thanks.
Bye.